Hey, Sammy, I was just I just left the meeting, came back trying to make sure that because the links looked to be different, was making sure I was the right call, but no one was on either one of them. So thank you for showing. So I know at least we're both in the right place.
Yeah, I think, sorry, I had another meeting conflict, 7 to 8 meeting, and ran a little bit later, so just able to join back. So I think let's wait. I think I didn't get a chance to send an agenda before. Maybe I think we should start 5 minutes or 10 minutes after. Generally, could be
Yeah,
people from another meeting they can roll up to. Let's wait for another few more minutes.
sure.
Yeah, thank you. By the way, like I was wanted to send starting out the week last week itself. I didn't get a chance to send a note.
No, I don't know what happened to this week. The whole week just got away from me too. So
Yeah.
Hello, good morning, everyone. This is Gopi.
Hi, Gopi. Good morning.
Hi, Sami. Yeah.
Travis, weather for you guys all okay? Here we are. Looks like we are going to get some cold, freezing things.
Yeah, it's going to be cold. That's what they predict. So let us see how it goes. How is it in Oregon?
It looks okay right now, but they're saying
Okay.
it's later today. It's going to be bad.
Oh, I see. Okay.
yeah, we were just talking the last call, but your Oregon forecast is really variable, right? It's like could be no snow or 14 inches of snow or
Yeah, we have not seen snow this year so far, but looks like it's going to show up this week.
Dump everything at once,
Right.
Yeah, here in Houston, the temperatures, we're getting that front too, and it's warm. It was actually really warm yesterday. It was in the mid 70s. It's in the 50s now, and then we're gonna drop below freezing by Monday.
Oh, really?
Yeah.
Wow.
Just depends on how that front moves, because like we're either going to get a little bit of cold or a lot of cold. Because it's like, yeah, I'm looking at the forecast here to show that we got like overnight lows on Monday and Tuesday of 18 and 20. So that's really cold for us. So
Oh yeah, really. Yeah.
Because we're used to 70s, 80s, and 90s, not
well,
20s.
it's like, yeah, we're used to it. It's the pipes are the ones that are really used to it. So stuff is just not as well preserved and insulated. This far south that we get shocked by that every year. But
Sure, yeah.
But we got such a good and this was just overnight lows. I mean, it's cold, but it's still going to get above freezing during the day. So that's usually enough to not cause us too much grief. It's when it stays below freezing for like 48 hours, then we get lots of problems. So yeah, we all and thanks to the government, I lost power the last time we had one of these for 3 days. So the house got really the pipes broke because well, it's just cold. So
right, yeah, that's
I
true.
was
Yeah.
lucky. Yeah, it was the stuff was mostly outside, so I didn't have any interior damage, luckily. But I got super lucky because there was a pipe broken above a bedroom, but it also broke outside, so so there was no water when it when I turned the water back.
Oh boy, sure, yeah.
Really lucky on that one because I took the opportunity, like, you know what, let's just replace those lines with the flexible PEX lines since they do run outside to a little outdoor kitchen area. You're like, why'd you guys run it out there and then turn back around and then run it back to the other to the bedroom that's like, yeah, you guys are clearly not up north. You would never run a pipe outside if you could avoid it.
Right, yeah. Yeah, it's a really, crazy designs they make, sometimes, at least if they provide earlier, we can do some modifications.
Exactly.
They don't share anything, right? Just a
No, it's all right.
nightmare, Yeah. Even the same thing here in the East Coast, DC area, even though we build a new house or anything of that nature, and they say anything oh, can you add another plug point here? Okay, sure, yeah, $500.
Oh yeah,
Oh, can
exactly.
you add the, yeah, they charge whatever they want, right? It's just ridiculous.
Well, and I had a builder build this house, and so yeah, I feel you. But I said, like, oh yeah, the custom builders, they don't nickel and dime you to death. No, they only work in $100 bills. That's
Yeah, right. And they offer something called design changes. Every design change is $2,500
right.
plus cost of the stuff. That's ridiculous, right? So, just if we want to add a bathroom,
Yeah.
and they charge like 2,500 plus the bathroom itself is $15,000. So it costs $15,000 just put a small change, So like put a shower, that's about it, nothing else,
Yeah, at least when I went through the process, and I had gone through that with friends, helping them with a lot of that stuff. But at least when I was doing it was a full custom, so it wasn't all the changes were like, yeah, let's just add more stuff. So it wasn't those fee based. It was just like, well, we're changing it, and we haven't built it, so it's just basically like, well, you're just adding the cost as if we were doing it up front, right? So it wasn't, you didn't get extra tax, right? But
sure.
But I did watch lots of other folks because I got to be good friends with the project manager, which is always a good idea.
Sure, yeah.
And hearing about all of their other really annoying clients, or at least probably more annoying than me, but yeah, it's like, well, yeah, our job is to not say no. Our job is just to say our job is to say yes, and here's how much it'll cost. So.
Oh boy, yeah.
But yeah, the amount of money you see people wasting when they do stuff like, well, they decided they didn't like the way that was looking, so they tore it all out and did it again. And like, oh my God, you guys couldn't have,
Right. That's true. Yeah.
Anyway.
And here in the DC area, contracts are weird. They take the money, they say, here it is. Okay, fine. So you need to give me 50% down. They come and do 2 days work.
Right.
They never show up for 5 weeks.
Yeah.
It's just, and some people lost the money. They ran away, right? It's just nightmare, So.
Oh yeah, it's like all things. There's a wide variety of quality.
Yeah. Right.
Wide variety.
Yeah.
And was it said, that was, depending on whose quote or who makes the quote, it's what 80% of the job is showing up or something like, it's always some high number. But I'm like, yep, that's about right. It's amazing how low the bar is. Showing up would be the first. That already puts you in the upper percentiles.
Right. Yeah. Because there's so much demand, people charge whatever they want, It's just amazing.
Well, and speaking of showing up, so it's 10 after. I think.
Yeah, right. Back to Sammy. So.
Yeah, I think Mohan is joining. So let's wait for a minute, and then I think let's go over I think Jeff gladly accepted to bring the profile overview.
Yep. I found a good presentation, or at least a decent one back from OCP Summit from wow, 6 years ago now. I have like 2018 doing the math. Holy crap. But at least it'll get through the basics, and then I can pull up a sample mock-up, or I mean a sample profile. We can look at it if you want to see.
Yeah, I think you have sample like where you can say certain features if available, then you can add another kind of capabilities there.
Yep. I'll pull that up in the background so I have it ready here.
Mohan joined. Hi, Mohan.
Yeah. Hey, good morning, Sammy. Morning.
So Mohan, Jeff is going to go through the profile overview, and looks like there is some sample profile for adding capabilities, and want to kind of
come on.
Okay.
Go through that. Yeah.
Okay, I'm on this. Just give me 1 second. I'll switch to my PC, and then we can see.
Sure.
I'll be able to see also. Yeah.
All right. Well, here, let me just I'll share my screen up here and get this get that presentation. And I'm looking to see.
2018, 5 years back.
That's really old now, isn't it? I'm sorry. I'm just.
That's okay. As a concept, I think it's good enough. Yeah.
I'm looking for. Oh, here we go. Okay, good. I got it. I got an example. All right. Yeah, I'm not going to do all. So y'all know what the goal are. So, just from a scope perspective, and I mean, I think I said this on our last meeting, or at least so some of you were in a different sustainability meeting, but so, and I authored the majority of the profile spec and concept. So, credit and blame all fall on me. So and folks have taken in some of this and run with it. And so I just wanted to give you a kind of a little grounding of like, this is what our intent was. And yeah, you can push the limits on the thing and it will probably work, but it was not our intent. So, we were trying to make the profile as a, hey, here's the data that I need to be able to retrieve, via the Redfish interface from a particular, class of product. So, and so you see, these are all very 6-year-old, NAS box, or, it would be something like, okay, this is the data I would expect from this class of product. And the intent here is to enable folks to write client code, that can start to rely on certain pieces of data being available. Right. So you don't have to solve this exception code of like, oh, well, if I can't find the product, vendor and model number, well, then I have to try to something else to be able to identify, it's those kind of things. So like, hey, I don't want to have to write a ton of exception code just to deal with folks that did a bad implementation. Right. So here's here's basically the profile that gives you that checklist of, hey, if this device meets this profile, then it means this data is available, in terms of the properties are available. You may not like the answers they give you, but the data, the structure is available, so your code will operate. And so that was a way for us, for folks to kind of meet in the market to say, hey, Mr. Vendor, do you guys have, if you meet my profile, then I know my code will execute, without error. And so that means that, that you'll meet my requirements. So the intent was that either customers or trade organizations like OCP would go create these profiles as a way to say, what makes a good implementation of, for a particular class of product. And obviously some of these things could apply across the board. And I think from our sustainability point of view, a standalone, sustainability data profile would absolutely make sense, because, and we should be able to write that just in a way that would say, look, it doesn't matter what kind of product you are, we can do some conditionals to say, well, hey, if you have a power supply, you have to give us power, you have to give us power data and things like that. So we should be able to do, I think, one of these. Anyway, so what the profile was not intended to do was, it was not trying to mandate a bunch of hardware, to actually support all that stuff. So I wasn't, the profile was not there trying to say, you have to have 5 fans in your platform. Like, no, it's trying to say that if you have fans, they need to be manageable, and I need to be able to retrieve the fan speeds. That's what the profile has went. So people, there are some gray areas there, and I think for our intent here, we probably are, mandating a little bit, because we're going to say, hey, I want you to be able to read power. Well, if you can't read the power, well, then then you got a problem. You got to go do some hardware. So anyway,
so your product can have multiple of other classes supported, right?
Oh yeah. So we can, well, we may be able to do some programmatic things, and that's what I was saying, that some of these conditionals we can make it so that the profile will still work. For instance, we're gonna make requirements about power and energy reporting, right? So, right. But and I think we would want to say that hey, if you have a large CPU complex, we would certainly think that you should be reporting the power for each individual CPU, or maybe that's our recommendation. Well, if you don't have those, if you're not exposing any of that stuff, well, then you can still pass the profile. It's like, well, I'm a single socket, ARM box, or I'm a big GPU platform. Like, well, it's the GPUs that you care about, not those other subsystems. So we can do some things to do some conditionals. But I think the the bigger one is really the, hey, you know, just make a different profile for if the category of product is really vastly different.
Okay.
You know, because for instance, I could craft a profile that would cover like all of these things with some big conditionals to try to say like, okay, the NAS box obviously has a lot of storage stuff. You know, maybe the front end doesn't have a bunch of, you know, that. But it would be a lot of work to do that. And what's the point? Where I could just make like 3 profiles, because, you know, as a customer, I would say, do you meet my NAS profile? Yes or no? And you're like, I don't care about these other things because they're not, you know, they're not for me. So, so trying to make this easy is the thing. So, yeah, so there's there's all the stuff that backs it up. There's both tools and some samples, and there's specification, and then obviously this is the profile stuff is done as a JSON document, so it's machine and human readable. We have the DMTF publishes 2 tools, which I'll get into. Well, I guess it's here. So there's the profile validator. So that consumes your profile document, and then you point it at a running system, and it will go, you know, check to see that the system is, you know, is actually meets the profile. So it goes and does that conformance check and produces a report to tell you, you know, did it pass or not. You can also take your profile document and run it through this documentation generator that will create. It won't create the usage guide that OCP wants to have, and that's fine. So it effectively produces a reference document. So it's good for a developer because it basically looks like the DMTF schema guides. It removes all the stuff that's not part of the profile, and then it adds a column for, you know, showing that, you know, this property has mandatory requirements, or some explanations as to why, you know, why those things are there. So it is useful in building that usage guide, but it won't be complete. But I'm certainly going to use it for you know, effectively the second half of it, and, you know, kind of the reference portions. Okay, so the actual structure of the profile, it's really in 3 parts, and you know, we can just effectively we're just gonna ignore this registry stuff because we won't need it for our purposes, but it's effectively the same. It's just it's a similar structure. So you really have some header stuff that basically just, you know, the you know, kind of name, rank, and serial number, you know, profile identification pieces. And some protocol requirements that if you want to place some things on the service, those are all pretty small issues that we probably won't get into. And then the bulk of the profile is in the resource requirements. And so the resource is, you know, in the Redfish terminology, that's a URI that's backed by a schema. And so since this deck was written, this has been expanded a bit, where you had well, each of these blocks was a resource or a schema, same thing. It's an interchangeable term. So, you know, if you had Ethernet interface, it would be, that's the name of the schema, and then it would apply to any of the Ethernet interface cases, you know, that you find in the tree. Since then, in the last year, we realized that because several a small number but a very important set of Redfish schema get reused in many places in the data model. Ethernet interface was kind of our early one, where, you know, because you can have an Ethernet interface on a system, but you can also have an Ethernet interface off of a manager. You know, the dedicated NIC for out-of-band management is our prototype example. And so you have different requirements for those 2 use cases. The cases we run into more today are things like circuit, because you have both input circuits and output circuits. And, you know, we may have different requirements on those. The one that we will absolutely run into is the schema called environment metrics, which provides the temperature and power and energy readings for any of the subsystems. And so it appears in dozens of places in the data model, because there's one under a processor, there's one under memory, there's one under drive, there's one under chassis. You know, any place that you could have a measurement point, that resource exists. so what we've added is the ability to effectively subdivide these to have, or just duplicate it. So instead of just being one entry for environment metrics, I can have what are called, what are called use cases, where I take the same schema and make a different set of requirements given some constraint. So what it did was it effectively elevated the conditional requirement capability up to the schema level. So what we say now is, look, based on the URI pattern, if environment metrics appears under a processor, then here are your requirements. And then set down here is like if environment metrics appears under a memory device, here are the requirements. And if it appears under a chassis here, so you can effectively replicate that over and over with a different, with a different subset.
So it's basically device level. Got one.
Yeah, you can do. I mean, you can make the restriction in a couple different ways. I'll have to switch to a different deck if you want to see how that works. But it's effectively this. It's very similar to what we do for a conditional requirement. So you can do it. The easiest way to do it, and I think the way that we would mostly recommend for folks, is based on the location in the tree. So, but you could also do it things like, oh, if it's this particular type of chassis. Or if it's like the sample case we gave was for memory, because the redfish memory schema can cover both an NV both NVDIMMs and DRAM. But you're going to have significantly more property requirements on an NVDIMM because there's a lot more data to understand. And so you would do two different use cases. You would say memory, and that would be like if memory type equals DRAM, and then the other one would be if memory type is NVDIMM.
Is there something like that, Jeff? Is there something like that? Because exactly, you took the very example I was hoping that you would take,
Yeah.
right? Memory with CXL has memory domain showing up under chassis and under systems, right?
Yep.
And there are different requirements. Is there something like this written for that?
Yes.
It is? Oh, would you?
Yeah, let me see if I can.
Yeah.
Let me see if I can pull up a. Okay, here, let me pull this up here.
So basically, like you have a device level and you have a system level, chassis level. To rack level, you can expand to DC level, right?
Where'd it go? There it is. Yeah, so this is not the same case that we just mentioned, but I'm pulling up the one from our sample that's published. And so this is the case of Ethernet interface. So this is the profile doc, and we're in the resources. So Ethernet interface is the name of the schema. And so I'm going to create two use cases for that schema. And so you can see there's an array of use cases.
Cool.
Okay. So basically, there's a few more properties, and then the rest of this is just like any other profile thing. So if I come up here to computer system, you'll see the same, version, purpose, and property requirements that just effectively gets moved down a level, into this array. So there's your, min, version, and property requirements.
Where do I go look for this, Jeff, on Redfish?
I'm sorry, say again.
Where do I look for this kind of use case?
Oh, well, this is in the interoperability profile spec.
Oh, okay.
And there's a bundle of stuff there. And the spec is DSP 20270, and then this sample and an adjacent schema to validate your own profile doc is in DSP 0272.
Okay, DSP 0270.
Yeah, and this use case stuff was added. I'm trying to think, it was in version 1.7 of the profile spec, so that should be the latest version, I think, too. So okay, so you can see, so I've got two use cases. Well, you can see off the screen, but I've got two use cases here. I've got, so my first use case, and so you get a name. So I'm saying this is the Ethernet interface for the manager, the BMC's, dedicated NIC. The only thing I'm giving as a requirement is the, well, how do I select this use case? Well, you meet this use case if you match this URI pattern. And so in the Redfish speak, you know, basically, look, I'm under managers and I'm under the managers Ethernet interfaces. And so it's basically anything that shows up in that, you know, in that location, you know, meets this use case. And so there, you know, and once it meets the use case, then, you know, then these requirements are then applied. And you can see this list of requirements is pretty small.
Just
So,
mandatory, so you need to
yeah,
give everything. Okay.
right. So actually, I say it's small, but it's actually a little different. But so yeah, so basically it's like you meet that thing, then I have to have, you know, MAC address and IP address and so forth. The difference, what am I doing here? Oh yeah. Yeah, it really doesn't look very different. This is a pretty trivial example, but you know, so the other use case is then, oh no, this is a NIC on the host. It's an Ethernet interface for the computer. It's, you know, for the server. And look, those can show up in two places. It could be shown as it's a simple NIC. It might be shown under Ethernet interfaces directly on the system, or it may be a network adapter in one of the more complicated models. And in their case, it shows up under the chassis under the network function ID. So, you know, and I see I've got a bug there. That's not good. I'll go fix that later. And so, you know, so if you meet those things, then you know, then there are things like the requirements are set. So that you can see there's some different things here. And I'm sorry that there's not a lot of delta here. The NVDIM and DIM case would be better. Let me see if I've got that handy, because I think we use that in the actual spec. Let me pull the spec up real quick. Yes, that's exactly the case we use. All right, so I'm going to switch windows again. Okay, this is when I realized I should just share my desktop. So this is the actual the profile spec itself. So when it talks about the use case functions, you know, in the section of you know, it's the heading is called resource use cases. So that's you can search for that. But there's the structure that we just kind of went through. So here's the example using DIM and NVDIM. So in this case, you know, there's a couple things that have to be met. So there's the URI pattern. So it's very similar to what we just showed. So it's like, hey, this is under computer systems and memory. So that's all system memory. And then it also has this use case comparison. And so it's saying using the key property called memory type. So that's a property in the memory schema. If memory type is equal to the values listed here, which there's only one value, DRAM. So if all of this is true, you know, so if I'm in the systems collection for memory and the memory type of that resource is equal to DRAM, then here are the things that are required. And in profile speak, sorry, hold on. So in profile speak, when you just list a property requirement with just the property name with no, you know, with no further details, that's a shorthand for it's just a mandatory requirement. Sorry, go ahead, Mon.
Oh no. I was looking. I'm trying to. I spent so many hours trying to reconcile the mockups with the schema on memory, and now I get it as to why you guys do. Okay, so it's because it's following this requirement. Okay, I got it.
Right. Yeah, so you can see. So I mean, this should be a realistic example, right? Like if it's a DIM, if it's a simple DRAM DIM, you know, the important data I'll get is, you know, I want to know what slot, you know, I need to know its location. That's the, you know, the socket numbers, you know, its capacity, the module manufacturer, the operating speed, and part number, right? So that's kind of that's the basics. So now look at this second use case, which is titled, you know, the NVDIM. And I cheated a little bit when I said it earlier. I said like, well, if it's an NVDIM, then you do this. Well, really, in the list of possible values for memory type, there's a bunch of technologies that all are categorized as non-volatile, as NVDIMs. But I don't want to try to list those out. And in fact, I don't want to list out the ones that we haven't invented yet. So we're going to make the assumption that basically if the memory type is not equal to DRAM, then it must fall into the NVDIM category. And I think that's a pretty reasonable assumption. So
basically the first section is a if condition. Is that the way we read it? If matches this, then you provide this.
Exactly. Yeah. Then you meet this. Then that resource meets this use case, and therefore these requirements now apply.
Oh, okay. Cool.
So you can see the difference here is that look, if this was a DRAM, then you can use a much older version of schema because there's the DRAM stuff was covered a long time ago, and you can see that you got just these 6 values there. But if you're an NVDIM, if you're not a DRAM in this selection process, then you got to be on a much newer version of schema, and you can see that while capacity and location of manufacturer and part number was there, now there's a whole bunch of more stuff there. So there's the capacity, there's the volatile capacity size, there's a bunch of there's a need for metrics and a device type. Then there's an environment metrics because there's dim temperature and power consumption. So you can see that list grows significantly. Now, and this is also probably truncated for brevity in the spec. So the NVDIM probably even has a bunch more stuff because there's a bunch of security related things that you probably want to have. So you can see that but that gives you a good realistic example.
So for our sustainability side, right? For example, like fan may not have a fan power measurement, so you can obviously cook a number and put it. And if you have a fan power measurement,
so it's that kind of stuff is what we want to make sure that when we write the profile that we don't want folks to encourage. Well, we don't want them to make up data to meet a profile.
Right.
So that's why we would do some of these use cases or some conditional requirements to make it so that look, if you're trying to report fan power, as I said in the meeting yesterday, we've added fan power is really at the subsystem level, so you get all of the fans as one power measurement, not individual fans, because that's asking too much, and also we don't, it doesn't serve a purpose. We don't want people to go add hardware for that. So I don't want them to try to synthesize that. So we wouldn't want to just say that fans had power. We would say that the subsystem would, or give some conditional requirements on the environment metrics. Say, hey, if this is reading fan information, then you don't need to have the power measurement at the individual fan level. So yeah, but we can do all that in the combination of requirements. In the combination of conditional requirements. So. And I know I hadn't gotten into that, and I'll show you that next here. But it's important to talk about the use cases first, because the use case, we figured out that because this is really doing the comparison or doing the division at a very high level, right? So DIM versus NVDIM. So what it avoids is that you don't have to go do all these conditional items on every single property to say, well, look, I don't need memory device type unless it's an NVDIM. So I would put conditional requirements on those things, but that becomes very, very messy for both the guy trying to write the profile and also for people reading it, because the way this stuff shows up in the documentation, it just shows up as 2 sets of requirements. So if I'm trying to write code or look at support for DIM, I get this list. I don't get this list with a whole bunch of this does not apply to you, to read through. So it's a better system overall. So I'm hoping that we can avoid the majority of our conditional requirements usage and just do use cases.
Okay. So basically the capacity and other things, location, everything is already available, but you're really put a wrapper around and say like, these are required if you support this type, if you say this particular use case, right?
Exactly.
Right. Okay.
Yeah, because I mean now, right, because and I guess I should have said that at the beginning. A profile is always a minimum set. It is not the maximum.
Right.
There is no way to restrict the vendor from implementing more than is required.
Correct.
That's a key tenet. Is like, look, you can add as much data as you want and all your OEM data, et cetera, et cetera. The profile will pass as long as you have the minimum. So, this could be a, if this was a DRAM and it had all of this other stuff, if, just for completeness or because it was a more advanced product, well, that's great. But it didn't matter for the sake of the profile. As long as you have these things, you pass.
But is there any optional way, like let us say you have a item, for example, like maybe a carbon. If you support carbon reporting, you should report this way, but it's not required or something like that, right?
Yep. Yeah. Here, let me just, that's a good place to go next. I could switch back to presentation, but I've got the spec open, so it works just as well here. Property, okay, read requirement, let me go there. So there's so each property, so, just as an example here. So here's is this one going to work? This is kind of a complex one, but, all right, well, you'll get the gist here. So here's the power, we're in the power schema. So I'm looking at the property level requirements there. So in that schema, and this is not a great example, but there's a property called power supplies, which is unfortunately an array. So it's an object that's got this. So I'm just let me pop down here. So here are the requirements for an individual power supply. So there are 5. So I need status, power supply type, line voltage, power capacity, and input ranges. So those are my requirements. And so, as I said before, there's status with no further details. It just says, so that just means it's a mandatory requirement. That's just shorthand. So look here at input ranges. So this property actually calls out what its read requirement is, and there it says recommended. So whereas the default was mandatory.
Oh, okay.
There is recommended. So what it says is like, look, as I read through this profile, it's mandatory that you have the power supplies, but down deep in the individual power supply, if you don't have, you must have your line input voltage, you must have your power capacity, and you must have a status and a power supply type, because all those don't say anything about it. But input ranges, if you don't have that, that's just a recommended value. So
that's okay if you don't provide it. Okay.
Right. And there are some other, So there are some other values for that read requirement. So the two that we show, is mandatory and recommended. There's a couple other categories of if implemented, which is a conditional for doing it at kind of an object level. So you say like, hey, if you had a power supply, well, then you have to have these properties. But if you don't have power supplies, well, then none of this is necessary. And then there's another one called supported, which says that, hey, there may be a whole bunch of these things, in the collection. And you just need to make sure that functionality is actually supported by the service. But if this was like, for instance, an NVDIM related property, but I pointed my validator at a system that had no NVDIMs installed and just, they were all just DRAM, I might not see a bunch of properties. So what this is saying is that, look, this property has to be at least supported by the service. But if the devices don't, if it doesn't show up because those devices aren't populated, well, then you can't, you're not going to see it. But that's trying to help folks to give an exception to say, yeah, it didn't show up there, but it would have if you put the right hardware in place. I should stop there because this is getting into areas that we will probably not encounter for our purposes here.
No, it's good to understand, right? I mean, we can see the conditional, right? you're also saying
yeah,
like
the conditional is what I want to get to next. So the conditional is the like, okay, so this is like, well, wait a minute, the property is required if the conditional requirements are met. So let's see, there's an example of that, should be right here. There we go. So kind of back to that Ethernet interface case, I'm going to use this one. So IPv6 addresses. Well, a lot of the BMCs, they don't support, they didn't support IPv6. They were just IPv4. But a system NIC, absolutely should have that, and therefore I should get all that IPv6 information. So what we do here is well, it's kind of a strange one. I said that wrong. I should have read my example. So what it's saying here is, look, in all cases, IPv6 addresses are required, or that's mandatory, and you need to have at least one. But if you have, if you have, if and this is an old way of doing it, but if you were if you're a system NIC as opposed to the BMC's NIC, then you needed to support a minimum of 2 IPv6 addresses. It's not a great example. I'm sorry.
No, we get it. We get it. No, this is very useful.
Well, here's the I was trying to avoid hosting because I thought it was more complicated, but no, this is actually the simpler example. So host name. Well, I don't I may not have that on some cases because it may not be the DNS service may not be used. But if you're on so if you're you may be somewhere, but so I'm like, okay, you know what? That's just recommended. It's not required. If you don't support DNS on your small device, that's fine. But if you're an Ethernet interface on a server, on a computer system, Ethernet interface collection, then that gets promoted to a mandatory requirement. So that's really the kind of the typical thing that I would expect to look. Is that you'll see a read requirement or recommended, and then some conditional requirement that turns it into a mandatory thing.
So is there any tools available to check and say like you have not provided this or that, or kind of I mean, if you code it wrong, is it a tool available to check the cross conditions and make sure that it meets?
I don't have a profile validator in the sense of, did you make a nonsensical profile? I don't have that. What I do have is the schema that describes the profile language in terms of as a JSON schema. So you can at least validate that you have written a valid profile as far as JSON schema is concerned, so that the tools can process it. Now, will it make sense when you spit it out? I don't have a tool to do that, and it would be a really complicated tool. So
I haven't been able to find this place on GitHub so far, the one that you're at.
oh, it's in. Well, the good news is that it's there's a new source for this because what you're seeing there was the internal GitHub.
Oh, that's why. Okay.
But while I'm here, and I'm not showing anything confidential. That's why I'm doing it. Okay. There's a new repository. This is a new public repository called Redfish Publications. And that the profile spec is not up here. I just pointed this, but all of the schemas are all, and the dictionaries are all published here now. So it actually allows you to do a GitHub, clone and sync to get all the latest schemas. But we didn't pull all the documents here, so you still have to, you just go to the DMTF site to get there's the that's I think I may have told you wrong. So 272, that was the specification. Here, let me just do that. So 270.
Yeah, I saw 270.
Oh,
I already
no,
have 270.
I'm sorry, that's not right. Is it 270? I've done this wrong. That's hold on, let me get you the right number. Okay, 272 is the specification, and then okay, I'm sorry, 8013 was way off. 8013 is the profile bundle, so that's where the sample is, and then the JSON schema to validate your profile file.
Ah, good, found it. Yeah, 22. That's the latest. Okay.
Yeah. That's your role. Yes. Like look at this. Like is it well? Okay. Well, is that really correct? I need to go look at that. That feels like
It
it's
says
not.
January 23rd, January 23. So 1 year ago, almost a year ago.
I need to double check that because that feels like that should have been updated. Was it really that? Let me see what version I was looking at here. Because this version's got the use cases in it. I'm looking at the raw source, unfortunately. So, oh, that was version 170. When did that? I think that link is out of date. Oh no. Okay. Well, I'm talking ahead of myself then, but that's okay. That material is coming out today. So.
Oh. Luckily, I think everybody in this call is part of.
Yeah, but if you're listening on the recording after today, that's fine because it'll all be public information tomorrow. Oh, crap! I thought honestly I thought we had that. I thought that I all got out in the last release, but I mean that's what you get for going on vacation on the holidays. all the use cases.
If you need to hold the recording for release, Sammy can do that.
No.
Sammy's the owner.
Okay, I'm not.
Or it's just the three of us. We may just delete it.
Yeah, exactly. You can delete it.
I'm not concerned. It was just holding for IP review, but the 30 days I believe ends today. So.
Okay. Yeah, we don't want you to get into trouble.
No, exactly. Yeah. I could get in trouble only in the spirit of the law. There's nothing here that's that anyone's going to be shocked or confused about.
Are there any GPU definition, accelerator, and other things in this, or we can add it as we move along?
Yeah, we can add it, but the way that you would spec, if you want to put some specs on here, let's pull this up. So GPUs are under the processor. So if I go to the
okay. Mm-hmm.
There's a property called processor type. PPP, it's under.
I see. It is rolled up under that. Okay.
Processor type. There we go. So here are the types, and so
okay.
So there's CPU, GPU. So and you can make a list of these. So you could say a use case of, hey, if this is a CPU, then then this replies. If it's if it's one of the programmable pieces like FPGA or DSP or GPU, then it meets these. And then things like core and thread, those might be something that are either not part or those are portions of a CPU. So it does not apply. But we can you can do a combination of lists or not equal, and like I done the NVDIM here. I'll show you the reason for that. So if I just search for memory type, there. So here in the memory type, you can see that we had DRAM, but then you had Optane, F, N, and P types of NVDIM. So I didn't want to have to list all these out and then wait for the next variation to come. So it's like, okay, look, DRAM's the only volatile. All the rest of these are non-volatile. So like, I'm going to assume that anything else we create will be non-volatile. So in the hope of not having to update the profile, we'll just do not equal to DRAM equals an NVDIM.
Okay. Yeah, that sounds good.
Yeah, again, trying to make the profiles as low maintenance as possible.
Yeah, definitely. Yeah.
So this one, that bundle, you basically like go to schema. It's not like online. You have to download the bundle to see it.
No, it's online now. The specs are the specs you download as PDFs. Right. But if you go to that Redfish, where was I at? See, I have too many tabs that all say Redfish. This is very typical. Welcome to my world. Where'd it go? I had it. Oh, fine. I'll just go there again. Doggone it.
Probably should start closing some of them.
Yeah, exactly.
Easier.
Well, but I use those. Redfish publications.
Right.
So if you just want to browse the stuff online, which I wouldn't necessarily recommend because you know the schema guides are much easier to read, but you can go read the raw. I mean, here if I'll go up the pull up that processor one. So I mean, here's the processor schema, you know, in the original CSDL XML language. So if you need to reference something to somebody, now you actually can go, you can make a hard link now to GitHub to point something to somebody to say, look, here's what socket means. It's line 188, and I can make a link to that, right? So that's what
this is a detailed on the previous page you had, like you are going through the links and you can.
Yeah. So that's the schema guide, and so that is this document here, the Redfish schema guide.
Oh, okay, 2046. Okay.
Yeah. So see, I think I'll open the window here. So I was using an HTML version of that. This is the the PDF, but it has everything linkable. So I can just scroll through here and you can see that it actually looks more like something a human could consume. But I go click on processor and then and then there's all these individual things, and then the go down to the prop. It breaks all that stuff out in the various types and so forth. So it's all presented in tables. And then all the values, so like here's all the values for instruction set.
Right. Okay.
But please look at this instead of the schema files. So there's no reason for you to suffer.
Right. Okay. This is good.
And quite frankly, almost all the information from the schema is now pulled into this file. So I mean, it has an awful lot of the details for here's the version it was added. There's the data types, the units, if there is such a thing, whether it's a read-write or read-only property. If it's a required one, there's a bunch of other little notes and things that pop up based on the schema annotations. So there is very little additional data you would glean so unless you're really developing those individual pieces, if you're writing a profile, it should be more than enough data.
Okay, this is good. So I think probably the next step, what we should be, I think this is a lot of good information. We should probably start putting some initial markup for sustainability.
Yep.
Right, then we can start adding additional stuff underneath, right?
Yeah. No, I think this is great. This allows us, instead of bugging you, Jeff, we can come back to you like I do on the other stuff, right? I can just say, here is the thing, and come back to. By the way,
when that new revision gets published, hopefully later today, you'll see a sample profile with the use case, so you'll see kind of how that works. And I said, the version. The example that's actually in the spec is probably a better example than what's in the file. But it'll get you to that use case, and that's what I would expect to use on so environment metrics. So because environment metrics is where all of the power and energy readings will show up. I'm sorry, the majority of them. There are some others specific for circuits and outlets. But this is going to be our main source for most products. So and you can see that there's a lot of places that this can show up in the model. And so I think that's where we'll start to say, okay, look, I think everywhere, we're going to talk about energy and power. And so there's power and watts. Yeah. So, that will probably just give a global thing. What we may want to put is to say, okay, look, there's lots of places where this shows up, but, mandatory, we're going to want you to have, kind of the main, right? The total power. So that would be like at the chassis level, or perhaps even the main chassis level. But, if you have individual metrics on, individual processors, then we may not, we may make that recommended, but we may not require that.
So there is a 3 or 4 things already there, right? There is a power related, energy related, and you said environment related.
Yep.
Is there anything carbon related there, or is it
There is
need to be?
there is not.
Okay.
It's for us to write, Sammy.
Okay.
But this has been I think we should have had this session a long time ago. Then you could have actually come back. Like thermal equipment, the way I came back to you with the markup, and I should have. Now we can do this instead of asking you guys stuff.
That's right. Well, well, the profile stuff is getting a lot of attention recently, but I mean, as you saw, the spec is like 6 years old, but we're still like I mean, the ones from OCP have been very, very minimal, and of course, those are ones that we originally did and threw over the wall. But so I want to, I want to, as taking the helm on that group, I really want to see more profiles, because this is how we get consistency in folks, in actually producing the data. So a lot of it is and we thought that folks would just do the right thing, but it turns out that, like, no, developers like to take orders. So, like, here's the list of stuff you have to do. Like, well, what should I do? Well, do what makes sense, guys. So but hey, if the profile is the thing that allows everyone to kind of shake their, to go nod their heads and say, yep, this is what we want, then so be it.
So that, like what you're showing right now, like 2023.2, it's a new one getting published today. That's what we should be referring to. That is our latest.
Yeah, the Redfish release, when it comes out, we put all that stuff in the same day.
Okay.
So yeah,
then I think
there'll be
let us look at it. Maybe let us create a summary of what is all related to the sustainability areas.
Yeah, and you should have that. And I did that, not down to the gory details, but I did that with a lot of the names and stuff in the presentation I gave back in July. And
correct.
And if you don't have that deck, I can send that out to you guys.
I will look at it, if not, or if you want to send it a note, that's fine too.
Okay.
I think probably next meeting, what we should do is here are the things already available, making sure that the complete list, and what are the new things need to be added. Maybe identifying that will be helpful. And also, I think we need to start discussing on a sustainability profile, how we want to put it, and then I believe all the algorithms and other things need to come in place, right? Maybe 3 to 4 different areas. I think we should start looking.
Yep. Yeah, and I'm thinking our profile is probably pretty small. It's probably the list of properties it has is probably, a dozen or maybe 15. And then we'll have some complexity on some conditionals on a couple of those.
Yeah, I think system level probably small. Maybe once you start going upper levels, like a chassis or a data center level.
Yep.
Then it may get a little more involved, probably, right?
Yep.
Yeah.
Well, I think that's where we want to start, and then
right.
then we can come back to say, okay, now let's add some recommendations for now that you got your basics, then we would also recommend that you break out, individual processor power, and things like that as recommendations.
Okay.
But let's start with our requirements first.
Yeah, sure. Very good. Thank you. I think we are already top of the hour. Thank you, Jeff.
I got to drop for another call too. So
yeah.
All right. Thank you.
Have a good weekend.
Thank you, Jeff.
Bye.
Yeah, you too. Thank you.
Thank you. We'll see you guys next week. Yeah.
Bye. Thanks, Sammy.